Here I will write the sum of floating point numbers once more. And why once more? Because you remember last time everybody might have been a little disappointed with the sum, because the sum was not exactly the one you were looking for. Like when you were expecting the sum to be maybe 31.5, the sum was turning out to be 31.499998, which is almost 31.5, but not exactly 31.5. It was 31.499998. Now, is there any way that I get rid of these extra points of decimal and only write the sum up to the points of decimal that I need? So, my idea is still the same, sum of floating point numbers, and let there be sum of n floating point numbers. So, how to write this program? Very simple. Firstly, I will start by declaring the float sum. You remember, the sum is still needed to be contained in a variable. Float sum is needed. Apart from that, an int I needs to be declared and n needs to be declared. So, n has to be inputted from the user. Let us keep it simple for the time being. Only let us consider up to that points of decimal. So, int I comma n and float sum, I declare this, and I get from the user printf enter the number of values to be entered. So, you scan that, basically that n you scan from the user. So, scanf %d ampersand n. Now, I will need this for loop for I is equal to 1, I less than equal to n, I plus plus. What I do is, over here, why I is equal to 1, I less than equal to n, I plus plus, so that I can scan n values, and after scanning that n values, every time that that value what I scan is has to be added to sum. So, sum must be this whatever I scan has to be added to the sum. So, I scan firstly, because n values needed to be scanned, scanf %f. What do you need to scan is a floating point number. So, why not ampersand fnum? So, fnum is a floating point number which I need to declare. So, declare that comma fnum, a floating point number that I declare. Now, after that, this fnum needs to be added to the sum. Sum plus is equal to fnum. So, this fnum needs to be added to the sum, and I is incrementing every time. So, once I reaches n, you will go out of the loop. So, what will happen is, basically n times this loop will iterate. Every time a new floating point number will be scanned, and that floating point number will be added to sum. So, the program will work exactly the way you want to. One thing you don't forget, that the sum needs to be initialized also. So, why not sum is equal to 0.0 initialized over here. Now, when you printf %f sum, here you remember, when you are printing, the problem that is happening is, it is not exactly printing the value. I want to show you what. Say alt R, enter. Sorry, I did not declare something, maybe. Oh, I did not comment out the program statement. Okay, so enter the number of values to be entered, maybe 4. So, 3.2, 7.9, 6.5, 4.8. See, what is the sum? 22.400002. Now, what is this? 3.2 plus 7.9 plus 6.5 plus 4.8. Let us make a very quick calculation. 3 and 7 is 10, 10 and 6 is 16, 16 and 4 is 20. So, the decimals before the point, it is 20. Now, after the decimal, 2 and 9, 11, 11 and 5, 16, 16 and 8, 24. So, basically it is 2.4. So, 20 plus 2.4 makes it 22.4. Now, 22.4 would have been the answer, but the answer is 22.400002. I told you why this is so, because internally, when the floating point numbers are being calculated internally, this whole thing is being converted to some binary format which consists of only 0 and 1, which is understood by the computer. Then again it is returned back to this decimal format, and as a result this little bit of error is creeping in. What if I want to avoid this little bit of error? It is very easy. You only tell C program to print, check out what? 0.2f. I was printing %f, a new thing. Oh, not here, sorry, this is scanning. The printing, over here I print 0.2f. While printing, you tell the C program that you print after this point, you print up to 2 places of decimals. Please check out, very simple. 0.2 will mean that 0.2 means point. After this point, 2 places of decimal you only print, not more than that. So you don't print 22.400002, you only print 22.40. So let me try this program once more. I believe you understand. Once more, if you want me to do 0.2f printing means whatever is the value of sum. The value of sum may be 22.400002 according to you internally. But I want you to print up to, after the point, I want you to print only up to 2 places of decimals. You could have made it 1 also, 1 places of decimal. That also I will see. So alter, enter. So again phone numbers. So 2.9, 3.7, 8.1 and 7.2, 21.90. Check out, only 2 places of decimal it has printed, not more than that. 2 plus 3 is 5, 5 plus 8 is 13, 13 plus 7 is 20. So before the point it is 20, now after the point, 9, 7, 1, 2, 9 and 7, 16, 16 and 1 is 17, 17 and 2 is 19, which is 1.9. So 20 and 1.9 is 21.90. So I believe you understand what you want. You can also change it to 0.1f. Here if you run, it will print up to 1 places of decimal. So let me run it. So phone numbers again, 2.3, 7.9, 6.5, 4.8. See, only up to 1 place of decimal. So 2 and 7 is 9, 9 and 6 is 15 and 4 is 19. Now 3 and 9 is 12, 12 and 5 is 17, 17 and 8 is 25, 2.5. So 19 and 2.5 is 21.5. Now you should be satisfied with the answer. Now one question that maybe is in your mind is, before the point can I change? Like instead of writing 0.1f, could I write maybe 7.1f? What does that mean? See, it still means that after the decimal you print up to 1 places of decimal. To make the things more understandable, instead of 1, I make this 2. So after the point, after the decimal, only 2 places of decimal will be printed. Now what does this 7 mean? What does this 7 mean? This 7 means, okay, let me run it and show you, because until unless I run it, you will not be very clear about what it means. So let me run and show you. But this 0.2 is for sure. The 0.2 will mean that it will print only up to 2 places of decimals. So let me run it once more. Alt, enter. So 4 values: 2.3, 7.9, 6.1, 4.9 or 4.8 maybe. So let me see what happens. The answer is 21.10. Have a look at that. This 2 plus 7 is 9, 9 and 6 is 14, 15, 15 and 4 is 19. Okay, 19. Then 3 and 9 is 12, 12 and 1 is 13, 13 and 8 is 21. So 2.1. So 19 and 2.1 makes it 21.1. 21.10 is absolutely correct because it is printing up to 2 places of decimal. But do you notice one thing? Few white blank spaces are left out before this printing of 21.10. what is these few places of blank spaces that are left out. To be precise, how many blank spaces are left out? See, 1 and 2, only 2 blank spaces are left out. Now if you look at that, you see 1 and 2 blank spaces. Firstly, when this 21.10 has been printed, firstly 1 and 2 blank spaces. After the 2 blank spaces, then 2, 1, 2 more spaces, so 4. After that point, 5 places. After that 1, 6 places. After that 0, how many? 7 places. I repeat once more. This 21.10 has been printed. Before 21, how many blank spaces? 1 and 2, only 2 blank spaces. After that 21 takes 2 spaces, so 4 spaces in total. Point, 5 places. Then 1, 0, 7 places. So 7 places have been occupied. See what you had written, 7.2f. This 7 will mean that you actually take 7 places to print the sum, including the number, including the whatever sum is there, including the 7, including the numbers after the point, including the numbers before the point, everything including 7 spaces. Change it to maybe 12.2f, alter enter again, or maybe to make it further different, 12.3f. Let me run it, alter enter. Enter the number of values, 4 again, 2.3, 4.9, 6.8, 1.6, 15.600. Remember, I had told 3 places of decimals, so it has taken 3 places of decimals. Now check out what? 2 and 4, 16 and 6, 22 and 1, 20, 2 and 4, 6, 6 and 6, 12, 12 and 1 is 13. So 13. And on the right side after the decimal, 3 and 9 is 12, 12 and 8 is 20, 20 and 6 is 26. So 2.6. So 13 and 2.6, 15.6 is absolutely correct. But it is 15.600 because 3 places of decimals. Now how many blank spaces have been left out? Check out before it, 1, 2, 3. And it has taken few more, 1, 2, 3 more, 3 and 3, 6. And then 15.600, all total 6. 6 and 6 makes it 12. It has taken 12 places to print 15.600. You check out what I had written, 12.3f. So I have told it, take 12 places in total, including the entire print of the sum, including the points after the numbers after decimal, whatever. Total 12 places have been taken. So you understand what I have tried to point out? So this is how it is done. Now one last question I will answer, one last thing I will answer before I end this and you take a bit of rest or take a bit of break. I will ask you, say when I was printing sum of not floating point numbers but decimal numbers, there also was this %2a, 2d, %3d possible? Say suppose sum was not floating point but decimal. I meant to ask you, is 12d possible? Let me check out once. Say this float, this is not float, this is int. So the whole thing is now being done over integer, that it is not a sum of n floating point numbers, but sum of n numbers, which are decimals. So let this be int sum, int fnum, not fnum, let me make it number only. Fnum means floating point numbers, the meaning gives something like that. So let us make it int number, int in, everything remains as it is. Enter the number of values, if this remains the same, sum is not 0.0 anymore, it is only 0. So sum is integer. So I don't scan %f, I only scan %d, and it is no more fnum, it is num. So see what I have done. I have told the user to enter the number of values to be entered, I have taken it in n. Now I have iterated a for loop from I1 to n, and every time I have scanned it, scanf %d, &num, I have scanned it within the value called num, the variable called num, and every time sum is being added, this num is being added to sum to get the decimal sum. And when I print %12d. To make it understandable, I make it 5d for the time being. See what happens. Alter, enter. Enter the number of values to be entered, say 4 values. 3, 5, 6, 2. So 3 and 5 is 8, 8 and 6 is 14, 14 and 2 is 16. See, it has printed 16, but see what it has done. It has done how many places it has left out before the 16? 1, 2, 3. Basically 3 blank spaces have been left out. So including 16, how many spaces it has taken? 3 blank spaces and 16. So 5, what I had written, 5D. I could have changed it to 12D. You run it, see 12 places it will take. So 4 values again, 3, 4, 5, 6. 3 and 4 is 7 and 5 is 12 and 6 is 18. So 18 it has been printed, but before 18 it has left out 10 blank spaces, and 18 takes 2 places, so 12 places in total. What you have written is %12D. So this works absolutely fine. I think you understand this. You can take a bit of break and we come back with the next program. Thank you so much.